Problem number 37. There's a lot of text here, but essentially what all of this boils down to is that we want to maximize d, which is equal to x plus 3y, where x squared plus y squared is equal to 100, and we also have the constraints that x and y both have to be non-negative. So in part A, I'm asking you, how do you tweak x and y to make d be the biggest it can be? Well, in order to do that, we have d written in terms of x and y. We want to get it down so d is just written in terms of x. How do we do that? So we have the relationship here, x squared plus y squared is equal to 10. So y squared is equal to 100 minus x squared, or y is equal to the square root of 100 minus x squared. We said x and y are both non-negative here, so it's okay to just take the positive square root. So really, the function we're trying to maximize, d of x, is going to be x plus 3 times y, 3 times the square root of 100 minus x squared. Okay, so we want to maximize this. What are the bounds here? What's the interval we can maximize on? So we're told x and y have to be non-negative. And so a little thought should convince us that the bounds here is that x has to be between 0 and 10. So x certainly has to be greater than or equal to 0. X has to be non-negative. If x is bigger than 10, then we're ending up here with 100 minus y is equal to 100 minus something bigger than 100. Y squared would be negative. That can't happen. And so these are going to be our bounds. So this is our goal. We want to maximize d of x equal to this function on this interval. So we know I have to check endpoints. Let's also look for critical points. So take the derivative here. We get 1 plus 3 times 1/2 times 100 minus x squared times negative 2x. And there should be a negative 1/2 here. So 3 comes down. The derivative of this be 1/2 times this raised to negative 1/2. Chain rule says multiply by negative 2x. Okay, so to look for critical points, we want this to equal 0. The only time this would be undefined would be if 100 minus x squared would be equal to 0. And that's already taken care of by an endpoint, so we don't have to worry about that. Okay, so let us work on solving this. Okay, so rearranging a smidge here, I think we should end up with 1 is equal to that 2 and that 2 will cancel. 3x divided by the square root of 100 minus x squared. If we cross multiply and square both sides, we'll have 100 minus x squared is equal to 9x quantity squared. Adding x squared to both sides, 100 is equal to 10x squared. X squared is equal to 10. And so this is going to have two solutions at x equal to plus or minus 10. But because x has to be between 0 and 10, we only care about x is equal to the square root of 10. Okay, so at this point, we have 3 values we need to check. X equal to 10 is our only critical point we found. And then the endpoints here, x is 0 and x is 10. So let's go ahead and check those. F of 0, or I shouldn't say f, I should say d of 0, d of square root 10, and d of 10. And we're going to plop everything into this equation right here. So d of 0 would be 0 plus 3 times the square root of 100 minus 0 squared. That would be square root of 100 is 10. 3 times 10 is 30. d of square root 10 would be square root 10 plus 3 times the square root of 100 minus the square root 10 squared. And so this would be square root of 10 plus 3 times 100 minus square root of 10 squared. That would be 100 minus 10 is 90. And the square root of 90 is 3 times the square root of 10. So it looks like we have 1 square root 10, 3 square root 10, 10 square root 10 here. And then finally, we need to check d of 10 here. Plug that in, and we would get 10 plus 3 times square root of 100 minus 10 squared. That will be 0, so we just have 10. So what's the biggest and what's the smallest here? So the biggest value is going to be 10 times the square root 10. That's going to be a little bit bigger than 30. And this is the smallest. So this is the absolute max, and this is the absolute min. So, okay, how do we adjust everything here? Let's answer, this is going to give us the answer to part A, this is going to give us the answer to part B, but let's fill in the x and the y values here. This is x is equal to square root 10, and this is x is equal to 10. If x is equal to 10, from this equation, y is 0. And if x is equal to the square root of 10, if you plug in square root 10 into here, y is equal to the square root of 90, or 3 square root 10. So these are the guides to tell you how you need to adjust x and y.